This is 6-7 in Advanced Algebra 2. Today, solving some radical equations. You know, they're not quite tubular. They're just radical, right? Radical equations. So you see in here that we have a square root, or any kind of root. It could be a cube root, fourth root, whatever. We got a root in here. Cool? Idea is the root on one side of the equation first. Is there anything being added or subtracted to that radical? We got. So we'll get rid of that plus 4. How do we get rid of that plus 4? Subtract 4. So the square root of x plus 2 should equal 3. Right? Now that the radical is isolated, let's get rid of that square root. How do you get rid of a square root? We'll square both sides. So we'll square this entire side and square that entire side. And over here, this is beauty, because the square and the square root cancel, and you're left with x plus 2, right? Just your radicand left over. And over here, what do you got left? 9. See how all the square root symbols and all that stuff disappeared now, finally, right? Now solve for x. Equals 7. Correct? But there's many times when we get extraneous answers when solving these radicals, so we got to go back to that old school thing and do our check. So put me a little squiggle right here. Let's do a check. And we substitute our solutions, or our possible solutions, back into the original problem. Here's our original problem right here. Square root of, you can do a little bit of mental math right there. If you got x plus 2 and we're saying x is 7, wouldn't that be square root of 9 plus 4 equals 7? Everyone see what I did right there? Put 7 in for x, and right here you had plus 2, so I just called that 9. 7 plus 2, 9. You with me? What's square root of 9? 3 plus 4 equals 7. Finish it, right? Be that good person and finish it. Does 7 equal 7? Yes or no? So check. That means that what we used for x was a solution. We will put all our solutions today in solution set. 7 was the solution to that basic equation. Pretty cozy? That one was real simple. Next one. Is the radical all by himself on one side of the equal symbol? Nope. What would you do first? Would you get rid of this times 2, or would you get rid of that minus 4? Get rid of the minus 4. So 2 square roots of 4x plus 8 comes down. Make sure you're keeping all that stuff underneath the radical. That'll equal big fat 12. Right? The radical's still not by himself. We got a times 2 in front of it. We can get rid of that real easy by dividing by 2. So what do we got over here, meow? 6. Now the radical is isolated, correct? Let's get rid of it. What kind of root is it, though? Square root, cube root, what is it? So how do you get rid of the square root? Square both sides. Square, square. The square and the square root cancel each other out. And that should equal 36, right? Now solve for x. Solve for x. 36 minus 8 is a 28, right? X equals 7. We got to check them all. We'll get some extraneous answers today. So check. We are checking. I'm going to put 7 in for x. So I got 2 radical 28 plus 8 minus 4 equals 8. I just did a little mental. I took 4 times 7 right there. Then we clean it up a little bit. 2 square roots of, what's 28 plus 8? Oh, I like that number. Then you got 6 times 2, which is 12, minus 4 equals 8. 8 equals 8. Checked. Solution set. 7 was a solution to this equation. Rock and roll? Be careful. Don't put 8 in the solution set. It goes in the solution set. Yes, ma'am. Next guy. Uh-oh. Something's real different in this problem. First 2 were warm-ups. Radicals. Supposed to get the radical all by himself on one side of the equal sign. Problem. 2 different radicals. Are they like terms? Can you add and subtract a radical 3x plus 1 with a radical 5x? Can you add radical 2's and radical 3's together? No, they're different things, right? Aren't radical 2's and radical 3's different things? This says 5x, this says 3x plus 1. Are they the same thing? So you can't add or subtract them together. So what do we got to do? Well, is there a radical all by itself on one side of the equal sign? So we can at least kind of like clear the radicals of this guy. We're going to square both sides again. But holy cow, how many terms are on the right side? How many terms? We got to group them and take that entire binomial and square it. So get with me. Those first two, real easy. Next one's not even close to as easy. You with me? Over here, this one's a piece of cake. This is the entire radical. This is a monomial over here. It's the entire radical being squared. What does the square and the square root do to each other? Cancel out, and you're left with 3x plus 1. Make sense? Over here, we have to do the binomial squared. You should know that shortcut by now, which is square the first guy, take twice the product, square the last guy. Cool? So let's do that. Let's square the first term. What's the square root of 5x squared? It's 5x. Twice the product. I need to multiply these two terms together in the first place. What's the negative 1 times radical 5x? Negative radical 5x. I need to double that. So wouldn't you get negative 2 square roots of 5x? Let me write it off to the side for you. Negative square roots of 5x times 2. Correct? You take numbers times numbers and radicals times radicals. You took the negative 1 times the 2, and there you got it. This radical had no one to play with. You with me on that? Last move, square the last guy. What's negative 1 squared? Plus 1. How are we doing? You see how I squared that binomial? Square the first guy, twice the product, square the last guy. Correct? Did that make it any better for us? Yes and no. Did it get rid of one of those radicals? Yep. Are there still radicals left over? So now we just start over again. Let's get the radical all by itself on one side of the equal sign. Don't we need to like move this guy over and move this guy over? Correct? So how can we get this positive 5x to go over to the other side? And if there's 3 x's over there already, and we're subtracting 5x, isn't there a negative 2x total? I subtracted 5x from both sides. Y'all with me right there? How do I get this plus 1 over there? Subtract 1, but there's already 1 over there, so what really results when you subtract 1? And you're left with negative 2 square roots of 5x. With me? Is the radical all by itself? So what will we do? Add 2 or divide by negative 2? So let's divide by a negative 2. And that would be x equals radical 5x. Correct? Is the radical all by himself? So now we can get rid of him again. How do you get rid of that square root? Square both sides. It just so happens that on the left side you'll have x squared, and on the right side you'll have 5x. Correct? So far so good. Oh dear, a quadratic equation now. Correct? An x squared and a 5x. You got an x to the first and an x to the second. When it's quadratic, get it equal to 0. So don't we need to subtract this guy over now? Correct? So I got x squared minus 5x equals 0. And now your favorite word comes out. It's time to factor this. Right? We could use the quadratic formula if you wanted to. This is very easy factor. What's the first thing to check for in factoring? GCF. GCF. Is there a GCF we can pull out of this guy? Yep, we can pull an x out of every guy. So it's really x times x minus 5 equals 0. With me? Now let's solve for x. What could x equal? X could equal 0 or 5. You down with that? Time to do a check. Maybe some of those are extraneous. So we'll check. We've got two different things to check. Correct? So first thing I'm going to check if x equals 0. Right, notice I'm putting it right here. I'm checking x equals 0. I go back to my original equation, and I'm going to put 0 in for x. So this would turn out to be how much if I put 0 in for x right there? 0 plus 1, which is, so I got the square root of 1 equals, if I put a 0 in for x right here, you got the square root of 0, which is 0, right? Minus 1. Correct? And what is the square root of 1 over here? Does 1 equal negative 1? So cross out the equal sign, go over here, and say no 0. All right, that one didn't work. That's an extraneous answer. Now let's check x equals 5. So if I put 5 in for x, I get the square root of 15 plus 1, which is really 16, right? Equals, putting 5 in for x, square root of 25, then minus 1. Do you see the minus 1 is not underneath the radical on the right side of the equal sign, right? So you got 4 equals 5 minus 1. 4 equals 4. That one worked. Check. So in our solution set, what was our solution to this situation? 5 only. Yay! Deceptively easy looking, not even close. Why was this one so much difficult than the other two? Because there was more than one radical in this equation, correct? So let's go again. Do we have more than one radical in this equation? Now listen to this. Is there one radical all by himself on one side of the equal sign? Yes. Let's get rid of that radical first by, if this is a square root, what would we do? Square both sides. Whop, whop. This is more than one term over here, so we'll have to square that entire binomial. Groovy? The left side's the piece of cake, because it's just one guy in the parentheses. That entire radical squared would give you x minus 12. Please use the binomial squared shortcut trick. Square the first guy, twice the product, square the last guy to get me the right side of this equation. 4 is the first guy squared. The product of those is negative 2 square roots of x. I need twice that, so minus 4 square roots of x. And then if I square the last guy, what do you get? Plus x, or minus x. Which one? Plus. You take a negative square roots of x times a negative square root of x. It's going to turn out to be positive x. Good deal? Yeah? Is there still radicals involved? Let's isolate this radical. We got to take these constants and these variables that have integer exponents over to the other side. So if I subtract the 4 over, won't you have a negative 16 on that side? If I subtract the x over, ooh, what happens to them x's? They're gone. So you're left with this, right? Yes? Now get the radical all by himself. So then the radical's all by himself, so we'll get rid of the radical by squaring, right? So 16 equals x, correct? Checking. Checking. Since there's only one thing, you don't necessarily have to put the x equals 16. It's the only thing we're checking. So square root of 4 equals 2 minus square root of 16. 2 equals 2 minus 4. 2 equals negative 2. Don't copy me. Just do it. I'll give you time. Nope. That was the only shot we got, right? So how many solutions does this bad boy have? No solutions. Empty set. You can put the set brackets with nothing in them if you wanted to. You can put the empty set symbol. This is an extraneous answer. Yay for extraneous answers. Next guy. How many radicals are in this problem? Piece of cake. Let's get this radical all by himself on one side of the equal sign. You with me? Subtract an 8. You guys got me? Okay. Now look at it. Just look at it for a second. Done. How do I know that there's no solutions to this? The square root of blah equals -6. Can the square root of something come out to be negative? I got a negative, a radical equaling a negative. Timeout. Do all radicals equal to negatives come out with no solutions? What if that was a cube root? Could it happen? Yep. What if it was a fifth root? Could it happen? What if it was a fourth root? Could it happen? No. Even roots can't come out to be negative. Even roots can't come out to be negative. Yes? Next one. How many radicals? 1. Let's isolate him. But he's not a square root. He's a cube root. He's a cube root. Isolate him. Isolate him. Don't forget your index all the time. That kind of gets lost with all the writing that we have to do on these. Once you get your radical isolated, check it with mine. Now, we're a smart group. We won't brain fart. I got to get rid of this radical. Squaring both sides ain't going to work. Why not? It's a cube root. How do you get rid of a cube root? Cube both sides. Cube, cube. This is the only thing in this cube root, or in this situation, so isn't it 2x plus 11 equals 3 cubed, which of course is 7. Yep, solve for x. Solve for x, solve for x, solve for x. This, so I got x equals that. 8, check. Squiggle. 4 times the cube root of 16 plus 11 minus 2 equals 10. That'd be the 4 times the cube root of 27 minus 2 equals 10. That's 3 times 4 is 12 minus 2 equals 10. 10 equals 10. Check. 8 is our solution. Yeah. Backside. Let's roll. Hey. What would you do first? Let's do it. Then get rid of the times shui. Some of these aren't going to come out so nice on your homework. You know, like 6 divided by 3 is 2. You might get a fraction over there. Don't let it scare you. Fractions are numbers just like everybody else. I got a fourth root. Get rid of the fourth root. How do you get rid of the fourth root? Raise both sides to the fourth power. Two to the fourth. 2 to the fourth. 2 to the fourth. How much? And after that, the piece of cake. Ooh. Make sure we check it. Putting 5 in, I get 16 in there. Remember, when we're checking, we're not trying to isolate the radical. We're trying to get the left side and the right side to turn out to be the same number. So I would love it if the left side turned out to be 0. So I'm just going to take 3 times the cube root of 16, which isn't the fourth root of 16, which isn't that 2, correct? Times 3 is 6 minus 6. Is that going to turn out to equal 0? That's how you check it. Don't try to isolate the radical, which it still works, like I said, but it's too much work, right? Just clean up what's over here. There's no variables at all. You're not trying to solve for anything. You're trying to check to see if 0 equals 0. Solution set. Yeah. Ah! Does this have a radical in it? No. But what kind of exponent is in it? Starts with an R. Rational exponent. Isn't that the same thing as the square root of 9x minus 11? So rational exponents, just like radicals, they need to be isolated on one side of the equal sign. Are they? Is it, I should say. Is it isolated? Yep. How do I get rid of the 1/2 power? Well, remember, you're trying to take a power to another power. Isn't this a second root right here? It's power over root. How do you get rid of a square root? Square both sides. Because if you take a power to a power, you're supposed to multiply the exponents. 1/2 times 2 turns out to be 1. Right? You get rid of the exponents altogether, and you get 9x minus 11. Looks like you got yourself a binomial squared over there on the right side. Square the first guy, twice the product, square the last guy. If you're in a pinch, you always just rewrite it times itself. Right? But we should be able to do this. Any more radicals or rational exponents or any of that left over? Nope. Now we got to get everything over to one side. How do I know I want to get this equal to 0 this time? This is a quadratic equation. It's got an x squared and an x to the first in it, right? So let's get it equal to 0. X squared still over there. I want to subtract 9x. There's 2x over there, so isn't that minus 7x? And then I want to add 11 and get a 12. Notice what I did. I got it equal to 0, but there's a whole other way to get it equal to 0. Couldn't you have brought all the stuff to the left side? And if you'd have done that, what would have been your term in front of the x squared? Would it have been a 1, or would it have been a... And we don't want that a value to be a negative 1. We want it to be a positive 1, because this is an easily factorable situation. Find two numbers that multiply together to be 12, and add together to be negative 7. Got them? What are they? Negative 3 and a negative 4, correct? So doesn't that puppy factor? Real simple. Now what are our two possible solutions? X could equal 3 or 4. Oh boy, gotta check them. Check. Since you have more than one, tell me which one you're checking right here. Let's check x equals 3. So I got 27 minus 11 to the 1/2 power equals 4. That's 3 plus 1, 4. Yeah? What's 27 minus 11? 16. And then you're taking it to the 1/2 power, which is really saying you're trying to do what to that 16? Square root it, which is 4 equals 4. That worked, right? So I'm going to go to my solution set and go ahead and put this particular one in, and we got to be careful. It's not 4 that works. Which one worked? 3. Now I'm going to go again and check x equals 4. Putting all my cool stuff in. And if it checks, then put our other solution in the solution set. Not too bad. The old factoring comes back to haunt us, though. Next, we've got a rational exponent. He's not isolated. Isolate that rational exponent. Isolate the rational exponent. Then once you get the rational exponent isolated, to get rid of that 1/3 power, how will we get rid of a 1/3 power, which is really a cube root, right? We'll cube both sides. This is a root. It's power over root. So let's cube both sides. 6x minus shui equals Did I make a mistake? Am I good? Okay. 8, right? So then 6x equals how much? 11. That means x would equal what? Oh, nasty. Good for it. Let's check him. Checking to see if x equals 11, 6. Oh, this is going to be pretty nice here. We're not putting back in. Look at this x right here. Isn't there a times 6 right next to it? And you got to divide by 6 in your x value. What does that times 6 and divide by 6 do to each other? And you're left with 11. You're taking 6 times 11 6 right there. Doesn't that turn out to just be 11? Correct? Times 6 and divide by 6 cancel? Yeah. Not so nasty. See if he checks out. This is 2 times another 2, which is a 4 minus 4 equals 0. Doodle, equal doodle. Go for him. Go for him. Go for him. Shouldn't we subtract 1 first? 3n plus 2 to the 1/3 equals -1. Stop there. Empty set, or should we keep going? Don't we have a negative equal to a quote-unquote radical, even though it's a rational exponent? Will there be no solutions to this bad boy? It's all about your root. What kind of root do we have, even or odd? Odd. So we can do that, right? We can take the cube root of both sides. Well, I mean, the cube root of something can turn out to be negative. Let me put it that way. The cube root of this could equal a -1. Possible. So how do you get rid of this? We cube both sides. What's -1 cubed? -1. -1. -1. And we got to check him. Check yourself before you wreck yourself. Check yourself. You'll get a -1 to the 1/3 plus 1 equals 0. This is saying cube root of -1. What's the cube root of -1? Since it's an odd root, you can do it. It's -1 plus 1 equals 0. Check them. Yeah. Four more down there. I don't think we need to do all 4 of them. Yeah, we will. I remember. We can do all 4 of them. They're not as nearly as long. So try yourself. See what you get here. Pause the video. Get that done. So on 11 should have came out like so for all you out there at video land. Next one. Being how this has 2 different radicals, we got one radical isolated. We will get rid of him first and then see what ends up happening. What'd you get? Did we get that far yet? Have we got a solution to this one? 12? Well, let's see. I'm going to square both sides. Right? What do you get over here? X plus 15 should equal 25 plus 10 square roots of x plus x. Square the first guy, twice the product, square the last guy. 2. Then x's, subtract them over, they disappear. Ooh, you get -10 equals 10 square roots of x, right? Subtracting 25, 15 minus 25 is -10. Everyone with me? Then divide by 10. What's -10 divided by +10? -1 equals the square root of x, right? So you could maybe stop there and realize, don't you have a square root coming out negative? Correct? How many solutions are there to this? No solutions. If you continued further and squared both sides, People are like, but if you square it, this is going to come out positive. You are right. That will come out positive over there. And if you get x equals 1 and you check x equals 1, should x equals 1 work when you check it? You should get an extraneous answer. Get the square root of 16 equals 5 plus the square root of 1. Square root of 16 is 4. 5 plus 1 is not 4. It equals 6. It didn't work, right? So no matter if you realize it early or late, it's still not going to work. Keep rolling. Cube root. You subtract the 5 over and you get a negative 5 over there. It's all good. Since it's an odd root, you can still do the problem. See if you can find my stupidity. I was doing it all non-calculator. What's my stupidity here? What's negative 126 thirds really come out to be? It comes out nice, you know, negative 42. So don't be so stupid with me. But I just saw the times 3 and the divide by 3. I wasn't concerned about having a fraction. It still all worked out real nice, you know. Yep. Good deal. One more. I like seeing ones like these. You know, I could see it ahead of time. Don't you got to subtract 12 over? What kind of number will you get over here? Negative, right? And it's an even root. So done, baby. Done, done, done. So what we're doing now, we went to homework. I want to do one more problem together. We'll do number 11 together. Something's a little different about number 11 compared to the ones we did. How many radicals? 2. It's going to be one of them same old deals where we got to like square both sides to get rid of the square root, but I sure wouldn't want to square the left side the way it is right now. Like if I wrote this out and had to do squared equals squared and try to square the first guy, take twice the product of those, and square the last guy, that would be a big fat mess. The idea is, since there's more than one radical, can you isolate one radical? So see this minus the square roots of negative 2 minus 2x? Can we move them to the other side? So you got the square root of negative 3 minus 4x equals 1 plus the square root of negative 2 minus 2x. And even though you're like, well, it's still going to be a mess, you know, yes, it will. It will be much less of a mess because now that you have this radical isolated and you square both sides, on this side, you don't have like a couple of radicals in that binomial. You have a whole number and a radical, and that we can handle squaring much, much easier. Cool? So when you have more than one radical and they're on the same side, isolate one radical first. Okay? Why don't we just go ahead and finish this problem, see how well we do on it. Then I'll turn you loose. Give it a try, video people. So when you square the first guy, you get a 1. You take twice the product, you'll get 2 square roots of negative 2 minus 2x. And when you square the last guy, since it's a square root, right, the radical just disappears and you're left with what's underneath the radical. So I got to here. I still have a times 2 in front of the radical. What do you got to do? Well, you divide every term by 2, right? It's like all of a sudden there's people that are like, I don't know what to do. Same thing that we did in Algebra 1. Just because there's a radical, what do you do? Divide by 2, divide by 2, divide by 2, right? Can't you do that? So this is negative 1 minus x equals the square root. Negative 2 minus 2x, right? Now, that's a good point. People are like, hey, this is negative, right? It's not going to happen. Is there variables over there also? Yes or no? You don't have enough information to say there's no solutions yet. Okay? It's got to be equal to an entire constant, you know, because what if x turned out to be a negative 7? Maybe, just maybe, if you put a negative in here, wouldn't you have negative 1 minus a minus 7, you know, and it could come out positive right there. So you got to keep going. You've got to keep going. And what will we do to keep going? Yay for squaring each side. So I've squared both sides. Over here, this binomial, if you square the first guy, it's 1. The product of those is x, right? Because it's a negative times a negative, right? The product is x. Twice the product is 2x. Square the last guy, you get plus x squared. All cool with that? Then I'm going to get this equal to 0 because don't I have x to the first and x to the second also? But I'm going to do myself a little optical illusion favor. I rewrote this in standard form. I put the x squared first, the x second, and the constant last. And now I'll add this stuff over. Yepper. Yeah? Does this factor? What two numbers would you choose? Two numbers that multiply together to be 3, add together to be 4, 1 and 3, right? So x plus 1 and x plus 3 equals 0. Yeah? X could equal a -1 or a -3. Check time. Check them both. I'll let you do that. Maybe they work. Maybe they don't work. Oops. You substitute -1 in to check it. You'll get -3 plus 4 right there, which is the square root of 1 minus square root of 0. 1 equals 1. My bad. Didn't set it up right. Equals 1. 1 equals 1. Right? So that checked. Yes? Right? The other one, put x equals -3 in there. Come on.